Right, hi, this is AQA SS1B for June 2015. So first thing we do, read the question. The length of the aluminium baking foil on a roll may be modelled by a normal distribution of mean and standard deviation. So I would normally write this x is normally distributed with a mean of 91 and a standard deviation of 0.8 squared. Because when we say something is normally distributed, this is the general form that you would write it in. It's in the convention. Drawing a little sketch that we can use over and over again. Very generally, 91 is my mean, and I've got 0.8 as my standard deviation. The first question is asking, what's the probability that x is less than 90? If I do a little sketch again, we know we've got 91 here. 90 is less than that. We want that area. I'm going to call on my trusty calculator. This is a normal distribution, so we press distribution. It's normal. We're going to do cumulative. Because I know this goes right down to a very small value, I put an extremely small value of minus 9999999. Okay. Then I've got the upper value is 90, so that's all the area I'm looking for. I need to put a very similar answer in there. Go down and put in a standard deviation of 0.8. And yeah, here's a mean of 91. Once the correct information is in, I can execute, and I end up getting a mean of, oh, where's it gone? 0.1056. 0.1056. Okay, the next question. Not exactly 90 meters, so I want not exactly. So exactly would be that, and not would be that. If it was exactly 90, my probability would be 0, because you can never get exactly anything. So in this case, my answer is 1. It's one of those trick questions. Okay, between, probability of between. So I want 91 meters is less than x is less than 92.5. This is a dream on our calculators. I'll go up to this drawing up here. So we want 91 and 92.5. After that area for this question. Get your calculator back, exit once, go up and change your low value to 91, your upper value to 92.5, and press equals. And you come up with 0.4696. 4696. Okay, the final part B, the length of cling film on the roll may also be modelled by a normal distribution with the mean, I'll write this over here in white, so modelled by a normal distribution, so I'll change, of mean of 153 and a standard deviation of lambda in metres. So we don't know what that is. So it is required that 1% of the cling film should be less than. So we've got this picture of a normal distribution with a mean of 153 and a standard deviation that we need to find by the looks of things. 150 is less than that, so this is where 150 will be, and we're told that this area is 1%. So if that area is 1%, we need to find out what sigma is. So if we don't know what sigma or mu is, we have to use this formula. Okay. Now, we can adjust it, which is what we've talked about before. By multiplying through by that, I can make it sigma z equals x minus mu, which is much easier, and you can put this in your calculator at some point, which we'll get to. However, the first thing you've got to work out is z, because we know x is our 150, the value that we've seen that we're interested in. We know mu, because they've told us that's 153. We don't know sigma, we know that we don't know sigma, so we need z is the only other thing we need to find. So, we can find it using this formula, or no we can't, we can find it with our inverse normal. So I would go to my calculator, moved across slightly so you can see what I'm doing, exit, exit, exit. So I want to know what z value I will get when 1% is here. And I need, so with a z value, it means I'm talking about a normal distribution, inverse normal. I have to the left, left of my stick area, I want a percentage area of 0.01. Okay, This is, I want a Z, so my standard deviation is 1 and my mean is 0. By doing that, I can find out that the Z value I would get here is minus, lost it, 2.3263. 2.3263. And that will equal 150 sigma. And that will equal 150 minus 3, which is 3. Now, if you are terrified of using formulas and how to solve it, you can actually go to the equation part and we will solve it. Okay? So what we type in here then is minus 2.3263x. I know it's not x, but that's what we're going to use. Shift to decimal to give us an equals, and 3. Or you could put 153 minus, or 150 minus 3. Now that doesn't look like anything's happened, which it hasn't, so you need to press solve. So our solution for that equation is x equals minus 1, which it can't do. So something's wrong. Oh, because this is minus 3. That's what it is. That's it. Go back to here. You can never have a standard deviation at negative, so at least that's something we've learned. Right, solver, F3. In here, I'm going to change and put a minus in there. Solve it. And we get a positive answer. So my sigma is 1.289. Good, that's it.